Hey everyone, welcome to my Introduction LibGDX AI tutorial series video. In this video, I just kind of want to leave it as a placeholder to help you get around to the respective playlists under each topic that I have presented in front of you. As the videos become available, I will set up to where, as in my Box 3D joints tutorial video, you can click the links. It'll take you to the first video of those playlists, and then it kind of gets you started, and then you can learn about these topics. So with that, I'll just talk briefly on some of the topics about what they cover, and so you can kind of hear what might interest you to implement into your game. And so first we have telegrams. Something important with telegrams is it allows you to create like event-driven behavior in your game. Now, in general, event-driven anything is kind of a well-designed application structure or design that you should implement in almost any system. Event-driven allows things to kind of be asynchronous. They can do their own things until an event occurs, and then they act on those events. And so with that, you can send messages, telegrams, and each entity can send out like a certain message. It'll broadcast the message out, and whoever's supposed to hear that message or whoever's listening will act accordingly if they are programmed to act on that received message. And so that's kind of a basic idea of what telegrams are used for. So you can kind of have objects communicating with each other on their own, and telegrams kind of tie into some of these other AI behaviors, but we'll see that down the road. There might be an all-together video where you just kind of link a lot of this stuff together, and we'll probably be seeing this in some of my other game projects too. So with that, you also have steering behaviors, and steering behaviors allow you to have entities that move on their own. Steering behaviors kind of give entities their own idea of how they're supposed to move around in your world, and that can be anywhere from like how fast they're supposed to move, whether they like zigzag or hide behind objects or run away from objects or follow, like seek objects, such as like an enemy that's trying to get to a player, or a pet that follows around a player and then helps you out and does other things. So there's a lot of interesting things you can apply that to. And then we also have formation behaviors, which involves a multiple amount of entities. And as you can kind of see from the title of it, formation behaviors, you can make a way that the entities kind of are, they move with respect to each other's positions. And so let's say you have a group of enemies, and you want them to kind of be in patrol mode, and so you can set them up to where they're all in like a box kind of formation, like a square box formation lined up. Anything like create lines, circles, swarms, just in general, but they stay together, just anything like that. And then you also have pathfinding, and with that, I'm going to be showing you guys how to implement your own kind of A-star pathfinding algorithm that won't just involve tiled maps. You can pretty much overlay your own kind of node map that fits within your own game and create the use the heuristic model that you're supposed to use to be able to calculate those shortest paths without running into collisions. And there's a lot of interesting ways you can do that too. It just depends on the kind of game you're building, but we'll look into a few different things for that, different setups. And then we also come down to finite state machines, FSM, and decision trees. Now, this is one of the earlier known types of AI. It can also be the most complicated types because it really depends on how you structure your state machines. And if you can kind of think about it as from some of my previous videos with like a game screen manager, this is just a really basic example, but you have the game screen manager. You tell it to load up a certain screen state, such as the main menu. And then while it's in the main menu, if something occurs, then the main menu says, okay, I am done here. And so then the game screen manager will go out of the main screen state and move into the play state. And so That's kind of the larger scope of your game where you're going in and out of screens. But another general idea might be like, let's say you have a thermometer, and the thermometer is supposed to do things under certain temperature conditions. So like, let's say if the temperature goes over 20 degrees Fahrenheit, then you're supposed to turn on the cooling unit. If it goes under 18 degrees Fahrenheit, then you're supposed to turn off the cooling mechanism. So it'll kind of like, you start at the initial position of checking the temperature, and then if you notice you've hit a certain condition, such as going above 20 degrees Fahrenheit, then you go into that state that tells the cooling mechanism to turn on. It'll kind of stay in that state, and then once it's cooled down enough, it'll move back out of that state into the next state that it needs to be in. And so you just kind of design these state machines. I mean, that's kind of what it is. But these conditional statements, kind of like a flow of if statements, like if this is true, then do this, otherwise do this, and keep doing that loop. It's kind of just one big loop, staying in those states. And so with that, I'll kind of leave you guys to it, and I hope you enjoy what's to come, and see you guys around. Thanks for watching.